Hey everyone, welcome to homeschool, and finally the wait is over for all class 9 students. Sorry for delay of posting this chapter, and finally I have come up with this wonderful, the most awaiting and the very interesting chapter of class 9 science, that is gravitation, isn't it? So here in a chapter, let us understand every concept of gravitation clearly, okay? And you know what? This is the most fundamental aspect one must understand to know about more aspects of space science. So you all have witnessed recently India could successfully place Chandrayaan-3 on moon. So the entire nation, the entire world appreciates this particular invention, this particular breakthrough, isn't it? So how did this satellite has reached moon? So what is the connectivity between Earth and moon? Why does the moon revolve around Earth? So you all know the fundamental aspect, right? So if this is Earth, you know, the moon revolves around the Earth. And if you take up a solar system, sun is at the center and all planets revolve around the sun. Even our Earth revolve around the sun. So how does this happen in a space, right? And forget about the moon revolving around Earth, sun, the Earth revolving around sun. How are we standing on Earth? Okay, suppose if I throw this chalk piece, definitely it will fall down. So how does that happen? And you believe it or not, see, there is an attraction between chalk piece and me. And there is an attraction between you and me also. Okay, there is an attraction between this chalk piece and board. There is an attraction between me and this board. Okay, so every object in the universe attract with each other. Okay, see, but there is a condition for this attraction. There must be a condition for this attraction, right? See, it is because the earth pulling the objects are falling down. We are standing right on earth. We are not floating, right? We are not floating in a sky. We are not floating in a air. We are standing right on earth. And if somebody pulls us up, I mean, we finally drop onto earth. We'll fall back onto earth. And you have observed, right? The chalk piece falling on earth when I throw it from up. A ball falls on earth. Right? So this earth has got that attractive ability. It can attract everything on it. Okay, it pulls. Earth can pull every object towards it. Earth can pull. This sentence is very important. Every object towards it. Okay, right? So how does it pull? Because there is this pulling force, right? See, when a chalk piece, when I drop it, it falls down in the sense the earth must, you know, with the force it should pull towards itself. Okay, so that force is actually called as gravitational force. Okay, so let us understand first the real meaning of this very interesting force in our nature. Okay, so that is gravitational force. Okay, so with this gravitational force, you know, we all are pulled by earth. We all gets attracted by earth. Okay, and I already told you there is an attraction between chalk piece and me also. So with some force, I keep pulling a chalk piece. With some force, chalk piece also can pull me, but that you cannot see, right? So ma'am, how do you say this? See, never a chalk piece on its own come towards me, and never on my own I can go towards a chalk piece. But what am I saying? There is a force, okay, with which I can pull the chalk piece. Chalk piece can come towards me. And there is a force in a chalk piece also that can pull me towards, right? but this force is very, very little as compared to the force or the pull by a earth. Okay, both chalk piece and I are pulled by earth. You know, the force of this earth is dominating the force of me pulling this chalk piece towards me, and the force of chalk piece pulling me towards it. Okay, got to know? So gravitational force is everywhere. Every object in the universe gets attracted to each other, gets pulled by the another object. Okay, so that force is called as gravitational force. So if somebody asks you what is gravitational force, what is your answer? It is the attractive force. Attractive force. Every point that I write on a board is important to note down. Okay, so attractive force between the objects, having certain mass. Okay, so having mass. So I told you there is a condition for this gravitational force. Okay, here the objects must have mass. See, chalk piece has got a mass. I have a mass, right? So it is because the bodies have got mass that invisible force exists between us. You know, I have a force in me that can pull this chalk piece, and chalk piece has got a force within it. It can pull me towards it, but that is not visible practically because the force is very, very weak force that is there between me and chalk piece. Okay, the force applied by earth is too strong. That is why you can see when I drop this chalk piece, it falls onto the earth. When myself jump from a building, I can fall onto the earth because the force with which the earth is pulling all other objects is much greater than the same force that is there between the other objects which are smaller in masses. Okay, so hope the concept has become very, very clear to you, right? Fine. And it is because of this gravitational force only the moon is revolving around the earth. Every time the earth pulls the moon towards it. Okay, so that's the reason the moon continuously revolves around the earth, but moon never falls on the earth. Okay, you can ask me, ma'am, when chalk piece I threw it, it is falling onto the earth straight, but moon, as you said, earth is pulling the moon, right? Why does the moon doesn't fall on a earth? Because the force, the type of gravitational force that you observe between moon and earth is called as centripetal force. Okay, centripetal force. Okay, which it is this force that makes the moon to revolve around the earth. Okay, fine. With the same kind of gravitational force, even our earth is actually revolving around the sun. You know, always the smaller object gets pulled by the bigger object. Earth is really big as compared to a moon. Actually, moon also can pull the earth towards itself. Okay, but that is not seen with your eyes. That is not seen. Why? Because earth is such a big body. Okay, so always the object which has got larger mass can pull the smaller object towards itself more nicely. So it is because of this reason why only the moon is revolving the earth, but earth is not pulled towards moon, because moon is small in mass whereas earth is larger in mass. Okay, so the same concept here. All the planets revolve around the sun is because of this gravitational force of sun. So sun has got that invisible force with which it will pull all the planets towards itself. Okay, so that force is pulled towards the sun, right at the center of the sun. Okay, so the force is acting in the center of the sun. Okay, so that's the reason all the planets revolve around the sun. Okay, so now I think everybody understood what exactly we mean by gravitational force, right? So it is that attractive force that is present between any two objects. Okay, any two objects, but those objects must have masses. Okay, so that is more important. And now there is a law called universal law of gravitation. Universal law of gravitation. So this is the very first concept on which you have to pay 100% attention. Okay, universal law of gravitation. So let me tell you one thing. I have already told you there is a condition for a force, gravitational force to exert. Okay, so we know that gravitational force depends on mass, right? So definitely if you want to observe a force between two objects, the bodies must have, the objects must have masses, right? So universal law of gravitation means through this we can understand on what factors the gravitational force is dependent. Okay, so one of the factor is the mass. Likewise, there is another factor called distance on which this gravitational force is dependent. Okay, so there is a equation here. Based on the equation, you can actually say that on which factors this gravitational force is dependent. So this was found out by Sir Isaac Newton. Okay, you must have heard in your lower classes that an apple falling on a Newton's head led to the discovery of gravitation, right? So Newton was sitting under an apple tree. Suddenly apple fell on a Newton's head. So he thought, why is the apple falling onto the earth? Why are the things are pulled towards the earth? Why is the earth attracting everything towards it? Okay, so this idea led to the invention of gravitational force actually. And later the same idea was applied the way the moon is revolving around the earth. Okay, so the moon revolves around the earth without falling onto the earth, right? So Newton is the one who told that it is the same force, okay, that is there between earth and moon also. So the earth is actually attracting the moon towards itself. Okay, so that is the reason the moon is revolving around the earth, right? So this universal law of gravitation is also was also studied by Newton, and based on his experiments, based on his observation, he has given an equation for universal law of gravitation. Okay, so let us understand how that equation had come. Suppose if you have two bodies, this is one object. See, this is a bigger object, okay, with more mass. Let the mass of this object be capital M. And you also have a smaller object. Okay, smaller object will definitely have less mass, no? So let me call that mass as M. And we know that gravitational force, F is gravitational force, okay, F represents gravitational force. This gravitational force directly depends on these two masses, okay. So capital M and small m. Capital M is the mass of bigger object, small m is the mass of smaller object. So F is directly proportional to capital M and small m. Okay, directly proportional means directly depends. If this mass is more, force is more. If the product of mass is less, force is less. So that is what we mean by directly proportional. And not only that, if I consider the distance, you know, the center of this object and the center of this object, this distance, let me call it as D. Okay, and this gravitational force F is actually inversely proportional to square of distance. What is this D? Distance. Okay, so this is the distance between two objects. This is the symbol for writing between. Don't get confused. Okay, so distance between the two objects is D. So more the distance, if the distance between the object is more, what happens? The force that you observe between the object is very, very less. Lesser the distance, more is the force. That is what the meaning of this inversely proportional. Force is inversely proportional to distance. Force is directly proportional to product of masses. Okay, so if I combine this equation, how I can write? F is directly proportional to capital M small m and inversely proportional to D square. Okay, if I have to remove this symbol, I should introduce constant. So F is equal to, I'll introduce a constant called G. So G into capital M into small m divided by d square. This is what we mean by universal law of gravitation. Okay, so gravitational force, if you want to find out using this formula, you can find out. Suppose I told you, no, there is some attractive force, invisible force between me and chalk piece. If you want to identify how much is the force, you know, when you know my mass and when you know the mass of this chalk piece and also the distance, if you measure, substitute in a formula all the values and calculate, you get the force, gravitational force that is there between me and chalk piece. Okay, so this is how gravitational force can be calculated using this formula. And now understanding the terms is very important. Capital M is mass of bigger object, small m is mass of smaller object, and d is the distance between the two objects, and F is gravitational force. And coming to the constant that we have introduced, this is very important constant. This is called as gravitational constant. You have to remember its value. So scientists have calculated its value based on some experiments, and its value is 6.7 into 10 power minus 11. So this is a very important number that you need to remember. Okay, so this particular gravitational constant, it is there, no, it does not depend on, very important conceptual question it is, medium. So in which medium the objects are there, it doesn't depend on that medium. It does not depend on size and shape of objects also. Size and shape of objects doesn't have anything to do with gravitational constant, and its unit is Newton meter square per kg square. No need to mug up the unit. Okay, let us derive the unit of G. Okay, so here G is equal to, you know, I am rearranging a formula. I want the value of G, no? So I am finding G. G is equal to, this goes with F, right? So F into d square divided by capital M and small m. Say unit of force is Newton. You have studied in the previous chapter, right? About force, its unit and all. So unit of force is Newton, and d is what? Distance. Distance is always measured in meters, no? So d square is there, so meter square. Divided by mass is always measured in kg. So kg into kg. So what is the unit? Newton meter square by kg square. Okay, so this is the unit for gravitational constant. Very important to remember. Okay, so they'll ask you in the exam, define universal law of gravitation. So now I am giving you the statement. It states that so you can write it in your books. It states that every object in universe attract each other with a force. They attract with some force only, right? They should attract with some force. So with a force, that force only gravitational force, with a force directly proportional to, that means on which factor it is directly dependent? Mass. Directly proportional to. Okay, so very important definition. Product of it, we have multiplied the masses, no? So multiplication can also be called as product. Product of masses of objects and inversely proportional to, okay, square of distance between the objects. Okay, So this is what the definition for universal law of gravitation. Fine. So we have seen how equation has come, we have seen the constant, gravitational constant and its units, right? So now let us discuss about the properties of this gravity. So likewise, let us discuss the properties of gravitational force. Let me write this as GF. GF in the sense gravitational force. Gravitational force is always attractive force. Okay, it is not a repulsive force. See, when two magnets are kept near, what will happen? South pole, if they are near, they repel with each other. No, but this force is not like that. Between the two objects, see, this is like a wiper and this is a chalk piece. This has got a mass, this has got a mass. So there is an attraction. There is a force with which chalk piece pulls this wiper, and there is a force in this wiper with which it pulls the chalk piece. So that force, it's always an attractive force. Okay, so it's a pulling force between the two objects. So it's always an attractive force. And next one is, it is very weak force. Okay, it depends on the masses of object. See, ma'am, you said the chalk piece attracts this and this attracts this. Why are things are not moving towards each other, right? Because it's very weak. If things have to move, if a chalk piece has to move towards it, this must be really very larger object as compared to the earth. You know, both the things are standing on a earth, right? Earth is pulling both of them towards it. So if this fellow has to pull chalk piece towards itself, this fellow must be larger than earth. So here all objects are dominated by earth. That is why you can't see chalk piece moving towards it and this moving towards it, because we are all dominated by whose gravitational force? We are all dominated with this earth's gravitational force. So because of that earth's pulling force, you know, the objects are not moving with each other. Instead, all of us are pulled towards earth only. Okay, fine. So it is very weakest force. And next one is, you know, medium. Okay, so this is independent of medium. For CBSE board, they may ask the properties of gravitational force for 2 marks. So mention the 4 points at least. And the last point is, this obeys inverse square law. Okay, so these are the inverse square law in the sense, see here, force is inversely proportional to the square of some property, that is distance, no? So if something is inversely proportional to square, then it can be called as inverse square law. So these are the properties of gravitational force. So now, what are the applications of gravitational force? Let us list out the applications also. Okay, see, I have already told you, because of this Earth's gravitational force only, the moon revolves around Earth. Okay, and also what happens? The planets, the different planets revolve around whom? Around sun. Here sun has got more mass than earth, so that is the reason sun's gravitational force is more stronger. That's why the earth is pulled towards the sun. Okay, so here due to sun's gravitational force, all the planets are moving around the sun. Fine. And you have observed the tides in the oceans, right? High tide and low tides. These tides are also due to the gravitational forces of moon and sun. Okay, so it's also due to gravitational force itself. So these are the different applications, and the objects falling onto the ground, everything, all of them are due to gravitational force only. Okay, so that's all about this video, guys. So here, if I have to summarize everything, we understood what actually we mean by gravitational force, and what do we mean by universal law of gravitation, how to state, how to write the formula, and the constant, right, gravitational constant, properties of gravitational force we understood, applications of gravitational force we have understood. Okay, so problems also can be asked on this formula. All the problems I will teach you in a separate video. Okay, so as of now, This much is enough in this video. And about the next concept, that is free fall and the acceleration due to gravity, we will discuss in the next video. Thank you so much, and do like the video and don't forget to share the videos with your friends, and also do subscribe the channel for more interesting videos. Thank you so much.